Thanks so much, John. I presume you can all hear me. I shall presume that's the case. As you're all aware, this is the British study, which is a £1.8 million grant funded by the British Heart Foundation, where we're going to be looking at patients with severely impaired LV function with scar on their MRI scan, randomized to either implantable defibrillator or no implantable defibrillator, but with an ILR. We will also be recruiting patients to a registry who don't have SCAR. And I'm just going to really provide a brief update and a little plug for British Today to try to keep the ball rolling. So this is our vanguard phase of the British study, which was agreed with the British Heart Foundation. And across the bottom here, you can see the months. This was when we started in April, and we had to open one site. As you can see, the number of sites goes up quite quickly. We're now actually in month 12 of our study, and we needed to have 16 sites open. And one of our key successes is we've actually been able to open 18 sites, and have actually slightly slowed down opening of sites so that we can really prioritize recruitment. Recruitment has been a little more challenging, as would expect, over summer months, where we should have had 37 patients by the end of August. We actually had 28. We've now got 29 patients, and as you can see, we need to get another nearly 30 patients within September in order to stay on track. I suspect we have gone slightly off track, but I'm not discouraged at the moment because we're putting in place a number of contingencies, and where we're doing that, we're seeing that sites are starting to recruit to target. These are the sites that are open and the dates that they've opened, and the majority of them now have started to recruit. This is a patient video which I'd recommend anyone who has 5 minutes spare just to watch, particularly if you're going to be a site that's recruiting to British. It helps with the consent process and has been really useful at Southampton for aiding recruitment. The mitigations we're putting in to try and get the recruitment back on target is only opening sites when they've actually identified patients that they can approach for the study. What we were seeing is the sites open, they're then waiting to see if patients remodel for a month or two, and then only being able to start approaching them then. We're trying to do that preemptively now and have sites that are thinking about opening in the next 2 months looking for patients who might potentially be approachable. We're encouraging sites to involve the wider team, so not only in heart failure, but also key are the implanters, electrophysiologists, the registrars, heart failure nurses, because these patients are often sitting in the heart failure clinics. And then we're performing site visits quite early with sites if they're not recruiting within the first month or two in order to troubleshoot and identify any issues. So, Zachary.
Thanks, John. Hopefully you can see the slides.
Yes, we can.
Good. So I'm going to talk about the PROTECT-HF study, which is another BHF-funded study. And what we're looking at is comparing physiological pacing, and by that we mean conduction system pacing versus right ventricular pacing for patients with a bradycardia indication for pacing. So for more than 60 years, right ventricular myocardial pacing has been the gold standard for delivering ventricular pacing to patients who require ventricular pacing due to conduction system disease. And it's very effective at preventing bradycardia, so we immediately are able to increase cardiac output in patients who have a very slow heart rate. But the problem has been that whilst it's very effective at preventing bradycardia, we're not delivering normal physiological ventricular activation. As we all used to seeing on the ECG, that's a very broad QRS because it takes a long time for the stimulus from the right ventricular lead to propagate to the left ventricle. And so it takes longer to activate, and it doesn't activate in a normal physiological way. And we're now recognizing that right ventricular pacing can be harmful. So that in the David's trial, this took patients who had pre-existing ventricular impairment, and it showed that if you delivered right ventricular pacing to this population of patients, you increased the risk of death or heart failure hospitalization. But not only that, there's growing evidence that if you take people who have pre-existing normal ventricular function, that right ventricular pacing can be harmful. So in the MOST study, there's a clear relationship between the amount of ventricular pacing that was required and the risk of developing heart failure or being hospitalized due to heart failure. So this concept of right ventricular pacing induced cardiomyopathy, so the RV pacing seems to be the trigger for developing worsening heart failure, has led us to look at alternative ways for delivering ventricular pacing. And this is where we've targeted the conduction system pacing. So initially we looked at delivering the lead to the proximal conduction system with His bundle pacing. And you can see from the ECG here, this patient is getting His bundle pacing, and we have a very narrow QRS suggesting that the ventricles are activated very rapidly. One of the slight challenges with His bundle pacing was that there, in a proportion of patients, there's a rise in capture thresholds, which led, and some people have block, although a relatively small percentage, but they have block more distal to the His bundle. So that's led to a move towards targeting the left bundle by positioning a lead deep in the interventricular septum. And you can see with left bundle pacing, we're again able to get very narrow QRS complexes suggesting rapid left ventricular activation, albeit with a slight delay in right ventricular activation, as evidenced by the R prime in lead V1. So we've got a growing enthusiasm internationally for conduction system pacing on the back of some large observational data suggesting that conduction system pacing is technically feasible, associated in observational studies with relatively low complication rates. But what we need really before we have a major change in practice is high quality randomized controlled trial data, which is what we're trying to deliver with the PROTECT-HF study. So what we'll be going to be comparing is a conduction system pacing approach versus a right ventricular pacing approach in patients who have a bradycardia indication for pacing. And what we want to establish is whether physiological pacing is better than RV pacing in those who have a bradycardia indication for pacing with a predicted high requirement for ventricular pacing and an LVEF above 35%. The primary endpoint is going to be whether it is mortality and unplanned heart failure acute care, so hospital admissions or ambulatory diuretic therapy. Secondary endpoints we're looking at are daily patient activity, patient-reported symptoms, and quality of life. The need for later upgrades to biventricular pacing. And we have an echo substudy of 500 patients where we're going to do an echo within 6 weeks of device implantation and then at 2 years. And finally, we're going to look at NHS digital data. So initially, during the main study period, we're going to compare the NHS digital data as a method for collecting the endpoints compared to the standard method of direct participant contact and contact with centres. But the idea is then to use the NHS digital data to do even longer follow-up after the end of the main study. So this is going to be this is a single blinded, so patients blinded randomized study, and patients are being randomized 1-to-1 to RV pacing versus physiological pacing. The aim is that after they're recruited, that other than the 500 patients in the echo sub-study, their normal follow-up should happen, and then the study follow-up will be done virtually, and we'll be assessing regular intervals, mortality status, heart failure, morbidity, and the quality of life questionnaires, as well as device-based information such as AF burden, percentage of ventricular pacing, and the device-based measurement of patient activity. So essentially we're trying to recruit people who are likely to need lots of ventricular pacing. So the big focus is on patients with complete heart block or higher degree heart block, which are patient populations who are likely to go on and need pacing or atrial fibrillation with very slow response, or patients who are going to be planned for AV node ablation. So it's a multi-center study, but the big focus on the UK, as it's a BHF funded. We need to recruit 2,600 patients. We think about 2,000 of those should be recruited in the UK, with additional 600 internationally. So when we opened the study at Hammersmith just under 3 months ago, and we are now active. So again, big UK focus. So we're now just into the 3rd month. We've already got 12 centres open. There's a huge amount of enthusiasm from centres for opening sites. We've recruited more than 100 patients in the first 3 months, which is obviously suggests that the patient population is out there, and and that we're sort of on target at the moment. But obviously the curve gets steeper, and we need to get more and more centres on board to make sure that we achieve our very ambitious target of 2,600 patients. So
this is a study that's currently in underfunding application. So we've been shortlisted for the 2nd stage of RFPB. So we've got our fingers crossed. It's actually a feasibility trial of electronic healthcare intelligent tooling in primary care for quicker diagnosis of heart failure, which we've called ThinkHF. So our question for the study is whether it will be feasible to trial whether intelligent tooling in electronic health records in primary care reduces the number of hospital heart failure diagnoses and improves time to heart failure diagnosis. So a bit of background to the study. We all know that heart failure diagnosis in primary care is quite challenging. And despite the nice guidance on early testing for things like BMP testing, there still remains long delays. And a study reported in the past few years using national primary care data showed that only 24% of patients actually followed the diagnostic pathway in NICE guidance. Just under half of patients had no diagnostic tests or specialist referral recorded in their record prior to a heart failure diagnosis. Average time between symptom onset in primary care and diagnosis was over 2 years, and this was worse according to various socio-demographic characteristics. So for women, the most deprived patients and also multimorbid patients, perhaps comes as no surprise. Alarmingly, most patients were only diagnosed when admitted to hospital, or at least recorded in their routine record. We do know, and that's up to 70% currently, and we do know that these patients result in much worse outcomes. Now, many of you will be familiar with the 25 and 25 strategy led by Lynn Mackey-Thomas at the BSH, which has partnered with over 45 organisations with a shared ambition to reduce mortality by heart failure by 25% in 25 years. And that's looking at initiatives across the whole heart failure pathway, from prevention through to diagnosis, treatment, and beyond. So this feasibility study really is aligned with the diagnostic point. And our solution to the problem, which we want to test, is whether creating some form of decision support system that's electronic and embedded in GP systems that alerts GPs to patients with certain risk indicators and gives them tailored information that's required for triggering the diagnostic pathway will actually improve diagnosis. We do know that there's a lot of evidence that's come out recently that shows these support systems are successful. And actually, in a review of these studies that was reported recently, there was 94% success rate in improving care and outcomes across different practices in 32 randomized trials. So the evidence looks good, but we want to now apply it to heart failure diagnosis. So we've partnered with a specialist organisation at University of Nottingham called Primis, who partner with NHS and commercial industries to scale and spread and develop electronic tooling for primary care. They have done some work in heart failure already, looking at risk indicators that identify patients at risk of heart failure, called GRASP-HF. This is just to give you a bit of an idea of the indicators that have already been developed. The 3 white circles are the kind of main indicators, but basically it's patients that have had BMP tests but no diagnosis or referral, patients that have been referred but have no diagnosis. And I guess the main crux of patients is those with signs and symptoms presenting in routine consultation, but with no testing, referral or diagnosis. This group obviously is quite a big group. So what they have done is try to narrow it down and create subsets of patients with different risk factors, because they want to increase sensitivity, but also increase specificity of the patients coming forward. So we're going to work with that group to develop these risk indicators and then develop a prompt system. So the two aims of the project, firstly, will be to refine those risk indicators. To do that, we're going to use some national data sets, including the HFpEF registry, and we're going to use consensus approaches to decide which are the risk indicators we want to take forward. And then we're going to work with primers to develop the prompt called ThinkHF, which will provide the tailored information. So the second aim, which is the one I'm focusing on in this presentation, is then conducting a feasibility study to see if these prompts can be integrated into primary care in routine consultations. So it's a feasibility study, but we have embedded a process evaluation. So we're going to select 4 general practices to try this out. There'll be 2 general practices at first, trying out the intervention for 4 months. We will then redefine or redevelop the intervention and try it out in 2 more practices. We will give training to the GPs or advanced nurses that are involved in diagnosis. We will take some baseline information, so looking at how much of their practice population actually has the baseline indicators. And then we will, part of the process evaluation will be to send a questionnaire to the GPs on their knowledge and comfort with heart failure diagnosis, and we will also have a look at that at the end via a post-study survey. Part of the process evaluation will be to interview patients to see how they think their consultation experience could improve and their sort of barriers to prompt diagnosis. And we'll also do some interviews with the GPs to find out about the mechanisms of implementation, the barriers and facilitators before measuring outcomes. This is what the framework of the sort of schematic of the ThinkHF. So patients attending in routine consultation with the risk indicators will flag in the alert tool that will alert a GP and provide tailored information on the things necessary to sort of create a diagnosis. That then will be fed into a prompt, which will prompt the necessary investigation, whether that be BMP or echo if the patient's already had a BMP, etc. So it will be tailored to the patient. We're going to include 4 practice in Leicestershire just for the feasibility study. Leicestershire has a very diverse population in terms of ethnicity and socio-demographic status. So we'll be selecting practices to represent that diversity. And there's quite a high sort of prevalence of patients with heart failure in Leicestershire. So we're hoping this will mean that we'll be able to look at this with patients with risk factors leading to heart failure. In terms of the patients coming through the practices, it will be any patient with those risk indicators as identified by the ThinkHF tool. The main endpoints we're going to measure in the feasibility study are around recruitment and retention. So how many practices stay retained in the study, how many GPs willing to take part, but also how many patients are present in the database, just to refine that sensitivity and specificity of the risk indicators. We'll be looking at effectiveness measures, mainly focusing on cost effectiveness in terms of data collection, the acceptability versus in the process evaluation, and how well the tool works. So, you know, is it correctly installed? Does it prompt where it should? And do GPs respond to those prompts? Just thinking forward to future trials, should this get funded, we've done a bit of sort of guesstimate on terms of sample size. So we think the primary outcome is probably going to be proportion of patients diagnosed in primary care with heart failure. We did consider time to diagnosis, but symptom recording is often quite sporadic. So we felt that was more subjective. So this is a more sort of objective measure that we'll probably focus on. Looking at the intercross correlation from previous CPRD work that we've done and variation in practice sizes from a review of general practices in the UK. Based on these numbers and a meaningful difference in the proportion of diagnoses would be a reduction by about 15%. Then we're looking at about 12 to 15 practices in each arm. And that's considering 3 to 5 patients per month might consult with the risk indicators over a period of about 12 months. But all this may change following the feasibility study. So we are at the stage 2 of an RFPB. If it's funded, we hope to go ahead in March 24 for 20 months. And then the plan will be to submit for an IHR, HTA or HSNDR full trial application.
From Joseph Bartonek. So I think this is a follow-on from that. So thank you. Take it away.
Right, can you hear me now?
Yes.
Lovely. Okay, so good. I spotted that mute button before you. I was told I was on mute. Okay, so
20p fine for that.
Absolutely. So so we probably all know that there's been a vogue for interventional cardiologists like myself trying to make holes. I close a lot of holes, and then we've got several devices that make holes. And the question is, does that make any sense? So the answer is we don't know. It should work by relieving the LA pressure, which relieves congestion and therefore relieves symptoms. And if we can relieve symptoms, that's obviously a big bonus because there's a large sum of patients, despite good medical therapy, that still are very symptomatic. So the FROST, it's a bit obtuse how the FROST comes out of that, but let's not talk about that. It's a double-blind, randomized, sham procedure-controlled global study. Difference from other studies, there's 2 different sizes of holes. I mean, who the hell knows what the right size hole actually is? It's varied between 6 and 10 in different trials. And so this trial tries to roll in a 6 and an 8. There's a roll-in phase because some centers won't be used to doing it. And there'll be a randomization between the 6 and the 8 of one procedure in a center that hasn't done this sort of thing before. But I'm hoping that all the centers that are taking part are used to transseptal punctures and putting devices into the heart. Otherwise, that would be quite a high event rate right at the start. So the roll-in phase has centers which are going to put in a 6 or an 8 device, and then it's randomized in the rest of the study between 6 and 8 devices to see what might be of major benefit. Its inclusion criteria are that you've been in hospital with heart failure, or you've got an elevated BNP, which in atrial fibrillation has to be even higher. If you've got an ejection fraction over 55%, so really quite spectacularly good LV function, then you've either had a wedge pressure which has been above 15 at rest within the previous 12 months, or an EDP within the previous 12 months that's been above 15. And you've got a limited 6-minute walk test, and a slight difference with some of the other current trials, you're allowed to have a device in. A lot of the other trials that are running at the moment have excluded devices, and thereby excluded quite a chunk of the heart failure population. But you have to have been stable on medical therapy or device therapy for a couple of months. So the exclusions are that you're in very advanced heart failure, you've within 4 weeks been in hospital, your LV is absolutely enormous. And the other thing is trying to find those where adding volume to the right atrium would be decremental. So trying to pick up those patients which have a RV, high systolic pressure, their RA volume is already very high, and people who've got some sort of other cardiomyopathy, so a hypertrophic cardiomyopathy, restrictive, infiltrative, something else, and not the standard muscle disease. And then if you already on pulmonary hypertension with specific drugs, you've got valve disease, which hasn't been sorted out properly. You're allowed to have a TAVI, for example, if that was 2 or 3 months ago. You're allowed to have a bypass, it was 2 or 3 months ago. You're allowed to have a stroke, it was 2 or 3 months ago. But people who are like to have a short-term prognosis disaster would be out. And of course, if your fluid balance cannot be managed except with dialysis, then I think it'd be very difficult to work out what the additional benefit of a hole in your heart actually would be. And then if you've already had a hole in the heart that was closed, obviously that's madness. So they sort of cover most of the inclusion and exclusion criteria with a primary endpoint, which is time to cardiovascular mortality or a transplant or an LVAD. number of hospitalizations in that first year, or intensification of therapy in that year, and then baseline and the KCCQ being done in follow-up. So I'm not a master at power calculation, but I'm assured that this is powered if the expected event rate is about 11% in the AFR arm and 16% in the control arm, that you would have 84% power at least to actually find out what was going on. And we'll be aiming for a total of about just over 500 patients. What's out there before? There's quite a number of trials running, and you can see the reduced LAP2, which was already published. Their website's amazing because it looks at the responder arm and shows amazing curves, despite the fact that the main study was negative. And it's the way with all of these. Pre-leave that you heard about had a signal towards lower left atrial pressure, but too small to actually say if a proper endpoint was reduced. And so I think the real answer will come when all of these trials have come, including FROST, to actually say, is there a group that clearly has a signal for benefit? The numbers in the trials are all pretty similar. The entry criteria are similar, except for the fact that we're allowing device therapy. And of course, if you've got very significant primary hypertension, you're out. And we've got this idea about the right atrial volume index as a way of actually picking up those that might not do well with an increased shunt. That's it.